Hey there, and welcome to Pomodoro Joe for Wednesday, November 1st, 2023. Today we're looking at LeetCode problem 501, Find Mode in Binary Tree Search. This is an easy problem. Cool. So, given the root of a binary tree, or a binary search tree, awesome, with duplicates, return all the modes, i.e. the most frequently occurred element in this tree. If the tree has more than one mode, return them in any order. Assume the binary search tree is defined as follows. The left subtree of the node contains only nodes with keys less than or equal to the node's key itself. The right subtree of a node contains only nodes with keys greater than or equal to the node's key, and both the left and right subtrees must also be binary search trees. So this is a standard binary search tree with, I guess, duplicates, so it's a little bit different. So this will have duplicates. We'll have a root node, everything to that left of the node, everything in its left child and below has to be equal to or less than that node's value, and anything in the right child and below has to be greater than or equal to that node's value. All right, so this says it's an easy problem, but this is not easy. All right, I'm gonna go through this pretty quickly though, try to keep up. So let's put 25 minutes on the Pomodoro timer and we will get started. All right, so for this one, I think I will just go through our tree by pushing nodes onto a stack or a queue. Yeah, it's more like a queue actually. So we'll be pushing nodes into our queue. These are nodes that we need to process. We'll process the node, we'll look for its left child, we'll look for its right child, we'll push those nodes onto the queue. So we'll push a node into our queue or onto our stack. Then we'll process each node while we still have some nodes in our stack or our queue. When we process our node, we'll look at its child nodes, the left node and the right node, and then we'll put those into the queue or onto the stack, depending on which one we go with. I think I will go with a queue. So let's do that. So let's see, let's start with some queue. And this is just going to be a list, and we're going to start with our root node in the queue. Let's see, what else will I need? I think I'll need to keep track of our numbers and their counts. So to do that, oh, this is going to be complicated. Right, to do that, I'm going to use a dictionary. So I'm going to have this dictionary of counts. That's just going to be a default dictionary. And this will be a default dictionary of integers. So the key, I'll make a note here, key is equal to the value, or the number I should call, number. And the value in this dictionary is going to be the counts. Let's see, I'm going to do an equals here. It's going to be a count of that key. Tricky. All right, so for every number we find in our tree, we're going to put it in our dictionary, and then we're going to keep a track of how many times we find that number. That's going to be the count. All right, so while we still have some nodes to process, so while our queue, let's grab a node. So node equals queue dot pop, and I'm going to pop it index 0. So we're going to grab a node out of our queue. Okay, now we'll add this node to our counts here. So counts for this node dot value plus equals 1. We have one more node with this value. Then we'll check, does this node have a left or right child? So if node dot left, we'll add this left child to our queue because we still need to process that node. And same thing for the right. All right, so we've just gone through, we've added our root node to the queue, and then we'll be popping nodes out of the queue. So we're going to grab a node from our queue, just like this list of nodes we need to process, grab one node out, process the node by adding its count to our counts, or adding one more to our count. And then we'll check the left and right child of that node. And then we'll add those to the queue for processing later. So that way we're going to go through our entire tree, basically keeping a count of all the different node values. Okay, now that we've done this, we need to find out which node value is the maximum node value. Or I should say, let me rephrase that. We need to find out which node count is the maximum node count. So which nodes appear the most. So to do this, I'll have some max node, or I'll call it max count. So the max count, I'm just going to use the max function here. So counts values. The values function called on a dictionary will just return all the values in that dictionary. Now for us, that's the counts. So we're going to grab all the counts and we're going to find the maximum one, and that's our max count. All right, and now we just need to go through every single key value pair in our dictionary, looking for keys that have this max count as their value. So which numbers have this max count? Then we can add that number to our result. So let's see, we'll have some result. It'll be a list. And then for every key and value in our dictionary of counts, and we have to do this, items. So this is another function that's available on dictionaries in Python. So essentially counts.items or dictionary.items will return all the items in our dictionary as key value pairs. So we're going to get the key and value out of our dictionary here. And if our value is equal to our max count, so we've found some number that was in our tree, and it's got a count equal to our maximum count, well then that number can be added to our result. So result dot append this value. Actually, no, it's the key that we're looking for. Result dot append this key. And then we can return our result at the end. All right, and this should do it. This is not what I would call an easy problem. All right, so we're going through, we're creating a queue, we're gonna add a root node to the queue. Then while we still have nodes in our queue, we're gonna pop each node out one at a time. We'll keep track of the count by adding 1 to our dictionary here, pushing in the left node or right node if we have any left or right nodes. That way we go through the entire tree, counting up how many times we find this key or this value. All right, then we'll get our maximum value. So we'll look for the maximum count in our counts dictionary. And finally, we'll go through and find all the different keys that have that max count as their value. Cool, let's see if this works. All right, seems to work. Let's see how we do. And we pass. And let's see, we do okay. We beat 55% for runtime and 86% for memory, so that's pretty good. Now if we jump in here, we can see, that's interesting. We're actually way at the top here, and yet we're only at a 50-something%. Huh. Yeah, it looks like other people are doing very similar things. I don't know. I'm not sure why we only get a 50-something% when we're grouped in here. I guess the variations are very slim. I don't know. Anyway, I think that's it. This is a fun one. Definitely not what I would call an easy problem. It's got a lot of different concepts you need to know, like queues. You need to know about dictionaries. You need to know about how to access their key value pairs. Not something that I would call easy, but it wasn't too bad. We got it done pretty quickly. So hope you enjoyed this. That is it for me. Hope you had fun. Hope you learned something. Hope you can go out and write better code.